It was so lovely to hear. Um, and a great intro. Um, so are people looking at the site now? Like what can we like
Yes.
describe stuff that's on it or
Wow, we've been continuing to flip back and forth to different projects. So I'll actually share screen so we can see it. For whatever reason, my Facebook Live is just giving me trouble. So I'm just checking to make sure. It says it's live, and I think I might need to believe it. But let me.
the site now? Like what?
Oh, there we go. Okay, cool. Yes, now we're good. I think it is officially working. All right, so I'll go ahead and share my screen because we'll go to the page, and then what we've been doing for the last few hours has been essentially having one of us guinea pigs, which in this case is me, going through the project while one of you, many of you, is coaching me on what to do, and we trying to grab information from those listening to see if we can figure out the answer together. So we're doing crowdsourcing times two by doing a crowdsourcing project while also having a crowd as one team. So should be fun. This is the project page. I'll go ahead and drop this in the chat for y'all. This is Planet 9 specifically, not Cool Neighbors. Planet 9.
Nine. Yeah. So as John pointed out, we're looking for objects in the sky. We're starting with a data set from NASA's Wide Field Infrared Explorer, which is really, really wide field. It observed the whole sky. In fact, it's observed the whole sky at least 11 times over. So, imagine think of how many stars that you look up and see. Um, we've got, we've got 2 billion objects that have been cataloged in the WISE catalog, and many more objects that have not been cataloged. And so we're looking at just a really, really vast data set. And that's why the project's been online since 2017 and hasn't closed down yet, is because there's still more to look at. And we're every like 6 or 8 months, I upload a new batch of data and we just chug through it and we make discoveries. As you can tell, the project was inspired by Planet Nine, right? So my thesis advisor is a dude named Michael Brown, who has this hypothesis that he's been pushing that there's another planet beyond Neptune, not Pluto. We know a fair bit about Pluto now, but that there's another massive object, maybe 6 Earth masses, orbiting the sun beyond Neptune and beyond Pluto. And so uh, we thought, hey, let's look for it. And worst comes to worst, maybe it doesn't exist. Maybe there's no Planet Nine to find, but we're sure as heck going to do a great job on finding these other objects called brown dwarfs.
Has
Um,
this may be a silly question, I guess, but Planet 9, did we figure out what's happening there? Like, have we determined if there is an actual planet?
you would have heard. It would have been
Okay,
good
I feel
to
like I
you.
might have just it might be something obvious
Yeah.
skipping over in my brain because I did hear a podcast at some point talking about like there's just mass happening, like some like evidence of mass, which maybe is something else that I heard that was unrelated, but I thought it might be that.
Hey, Mark.
John,
And you can correct me if I'm wrong. I thought, from what I've heard from some scientific models, that there has to be something out there because of all the mass pulling that's
Yeah.
happening with the gravitational shifting, and because no, and correct me if I'm wrong, nothing has ever been observed by telescope, but with all these different supercomputer models, they're showing all this tugging in these areas that seems like it would have to be some kind of a massive type planet to cause that type of gravitational pull.
yeah, yeah, that's the idea. So there are these objects in the outer solar system. Pluto is one of them, by the way. There are these objects in the outer solar system. It's kind of like a second asteroid belt out there, right? Except it's really cold asteroids. And these objects are called Kuiper Belt objects or trans-Neptunian objects. There are a whole lot of them. And they're patterns in their distribution. So there are a couple of different patterns in their distribution, which can very beautifully be explained by the presence of a massive planet mass object that pulls on them.
Yeah.
Exactly. So there may be other possible explanations. Um, but the planet picture works great. I mean, um,
We
it,
want it
it
to be.
it got me excited enough about the idea that I wanted to devote some serious time looking forward, and so did a lot of other people. So we figured we've got images of the entire sky, right, from the Wide Field Infrared Explorer. It can't really hide unless it's super faint. It's entirely possible that this planet is just too faint for us to see.
By
But
faint, like just not allowing any light through, like we, or what does that mean in terms of space? Again, silly question, but I just simply don't know.
not silly at all. Yeah, the planet shines in some, there's not a whole lot of reflected light from it, but we're looking in the infrared wavelengths. So in
Mm.
infrared wavelengths, we can see the planet's internal heat. And if the planet's massive enough, it has a fair bit of internal heat, and we could see that. So it's easier for us to spot it if it's a more massive planet. It's also easier for us to spot it if it's not too reflective, because then it absorbs more heat. Um, so um,
It is possible too, Mark, that it's got a very, very elliptical orbit that only allows it to come around so many thousands of years too. And that's why, unless you got your telescope pointing in the right direction or your spacecraft pointing in the right direction, that's probably the other reason why we're playing cat and mouse with it.
definitely playing cat and mouse with it. And it's possible that the planet is on the near side of the orbit, or it's possible on its at aphelion, its furthest distance from the sun. In which case, it'd be pretty hard for anybody to detect it, including us, except maybe for the Vera Rubin telescope, which is just ramping up.
Oh, very cool.
I'm seeing questions in the chat
Oh,
and comments from Lisa.
I didn't have the chat open. Would the planet be easier to spot if it were an ice giant or one with an icy or rocky surface? Eric, thanks for the question.
Yeah, I mean the planet's easier to spot if it's more massive. And the hypothesis is that it's about 6 Earth masses. And that puts it in kind of a smallish ice giant or super Earth kind of thing. Um, Probably more like a small ice giant.
We think it might be. I'm sorry, I had to close the door.
Yeah, yeah, we think it's some kind of a small ice giant.
Oh, some kind of a small ice giant just sounds so funny to me.
Yeah, yeah, like I don't know what's a small giant, a medium, a
Who
large.
knows?
It's
Well,
a nice large.
it's close enough to a
Yeah.
giant, but also small. Is it uh hard to describe? It's all these weird we've got some really fun terms going on in astrophysics, astronomy in general. So I'm glad that we get to use small ice giant. Now I just wanted to check. So for our team members on here who are part of these projects, in what way are you all involved? I know we heard from one of you, from John, but our other friends, are they split between the two projects or are they working on both or what's going on there? You can feel free to write in the
Actually,
chat
I'm
too.
curious. Let me ask them. Um, well, John, are you doing both Cool Neighbors and Planet Nine?
Yes, I am. I kind of take a break from one, go back to the other, and then kind of uh, use the tools I've learned from both. But yeah, I haven't done anything from Planet Nine for a while because it just seemed that was a little hard to really find anything. Uh, but I actually kind of got a little bit better with looking at an object, really looking to see if it's got any kind of movement in it. And then I'd go into visor with this
Is he gang?
reticence and declination, and I would see if it's really got true movement in it. And then I would throw it in the Astro Toolbox just to make sure it's got movement in it, and then make sure it's not in Sinbad. And then if it wasn't in any of those, then I'd go ahead and submit it. But yeah, I actually I started on Planet Nine, and then when I saw you guys were doing cool neighbors, I thought that would be another one to do, and so I'm doing both.
Oh, sweet. Well, thank you for that. And Naina Sharma also says she's doing both, and Ashwant says we do both. Awesome. They both projects, by the way, use the same data set. They're both looking at data from NASA's Wide Field Infrared Explorer.
Okay,
They just look at it in slightly different ways. Um,
gotcha. Well, should we test one out? We can kind of give you
sure.
count through it and see how we do. Okay, so you all can hopefully see my screen. Let me double check. Yeah, okay. So you're seeing what I'm seeing, but we'll go
Let's
through.
do let's do cool neighbors first. It's the easiest to explain.
Oh, okay, sure. Let me go back. Or unless you have a link to it on here, but I don't think you do. No, okay. Um, projects, cool neighbors. I have to do backyard worlds first. Backyard.
Hey, Mark, while she's getting ready to go to that, one thing I have noticed, and I know some of your A team has spotted it, I'm really glad you're not highly relying on everything on AI because it seems like AI kind of misses some of that, where the human eye catches a little bit more of that. So I'm glad that you're using the AI to filter it down and then using the actual human eye to make the final decision.
Yeah, absolutely. We the project works hand in hand with, the whatever computer software we could throw at this problem. And it's really helped tremendously to have humans. Um, we
Mhm.
we had this, there's this big team of professional astronomers that got a big grant to essentially do the same thing as us. And they tried to do it without help.
Mhm.
And they their work essentially stopped where at a certain faintness level, and then we picked up. There are whole regions of the sky that they weren't able to get to that we were able to get to. It was fun to see.
Yeah, it feels like the end old or like the age old story at this
Oh
point.
no, Cool Neighbors is okay. So Cool Neighbors has small. So Backyard Worlds Planet Nine has big batches of data, the whole sky, and Cool Neighbors is often used for checking smaller batches of data. So that makes sense why it's out of data right now. But I'm sure it'll be replenished soon.
Yeah, and I can still go through the tutorial if it's easier, because if you
Okay.
said generally it is easier
Yeah.
to like understand, it might be a good way to start and then we'll switch over when
Yeah.
we
Okay.
through.
That's great.
Yeah, because
Um,
yeah, there might be data wise.
could I call on one of my other team members? Maybe
Yes.
Lisa or Ashwant. Do you want to try introducing it?
I think you're being voluntold potentially, which you should be able to speak. Let me double check to make sure yeah, you should be able to speak. I can also move you all to becoming panelists too. Um, but I'll wait a moment.
Okay,
Having
Ashwant.
some technical hurdles. Okay. I
Uh,
mean, probably true, but also,
so the the project asks one simple question: Is there a moving object?
yeah,
And here we have picked a really, really bright moving object, so you can see what we're talking about.
absolutely. Yeah, it's a mover, right? Mover.
It's clearly a moving object. Now that object is illustrates why we need people to look at this. So wait, go back to that one if you don't mind. See, that object is it's moving, but it's not getting anywhere. So the previous example showed how there was a dot that clearly moved in a line, a linear motion. It went from left to right, right?
Hmm.
Moved in a line. This object kind of pulses, but it doesn't actually get anywhere. So don't count that. That's kind of a kind of noise. It's a ghost or an optical artifact. Then if you
Right.
scroll down, there are other examples of things. So there's stuff changing in that image. See the image there with the stripe?
Hmm.
There's stuff changing. There's little tiny dots like snow, like on a TV screen, right? In the background. That's just noise. They come and go, but they don't move in a line.
Right.
It's that kind of cool looking stripe, but uh, it's also not an object that's got some place to be, right?
Hmm.
Then the bottom, there's another object. And so I'd
Let's
also
see.
comment that the objects that we're looking for should be sort of star-like. They should remind you of a star. It should be kind of a dot, like a like a tight circle of light. And
Mhm.
that object is a big blob. That's not what we're looking for.
If it changes in size, that's an issue in general.
Yeah, it should not look like it should not change its size. So Ashwan says also called ghosts. Yeah.
Yeah.
So there are different ways that
Illusions.
light inside it's when light inside the telescope lands where it should not land,
Okay.
and um, it can create these things called ghosts.
You
Well,
can also
that's
sometimes mark see young stellar objects, which is where they look like they get big. Sometimes I know you guys have told me that those possibly could be an early star starting to form or brighten up. So that's why I say that the always using other tools to compare always makes a big difference.
Yeah. Yeah. So John, and in fact all of my teammates that are on tonight are real power users, and um we've got instructions in the project to that teach you how to use some professional tools to look investigate these objects further. So we can talk about that next. But are there any questions about cool neighbors? Because that's like the this is the most pure form of looking at WISE data. You see, there's star-like objects, points that move. That's what we hope to find. And then there are these ghosts, and then there's noise, and there's stripes.
yeah. We do have a question in the chat about more noise than others. So Eric asks, how come some frames have more noise than others?
Yeah.
Is there a reason for that, or is that just luck of the telescope process?
No, there are some parts of the sky that have uh just better signal to noise, and others they've been imaged more time, more the telescope has lingered there longer, has spent more time there collecting
Hmm,
data, so they're less noisy.
gotcha. Okay.
And there
And
are some objects, there are some parts of the sky that are near a bright star. Yeah, wait till you see an image. I'm sure we'll stumble on one where there's like a visible eye star there, a Myra or something like that, just like the whole thing exploded. Or there are frames that are in the galactic plane,
Mhm.
um, where like almost every pixel has got a star on it, and it's just like you could imagine the AI just giving up and going out for a smoke because there's no way it could possibly figure that out. I'm not condoning smoking,
Thanks for clarifying.
especially if you're an AI.
Okay, so if we classify or get started, we'll see the above screen. So if we, or the controls, let me go to the next one, see if we can see the visibility. Oh, just kidding, let me go back.
Yeah.
So on the right side, we have the controls, yes, bottom bar. So will we be moving through time essentially when we use the scroller bar?
Yes. So you see a sequence of frames that are taken months or years apart.
Oh, wow, okay.
Yeah.
Let's
And the
see.
idea is if it were Planet Nine, it would truck. It would just fly across the screen because that object is so close that um, the Earth's orbit around the sun makes
Oh,
it appear to move because sometimes it's ahead of us, sometimes it's behind us. So then
okay,
fly.
interesting.
If it exists, that thing is gonna cook. Um,
That's why I hope, Mark, every time I do an actual flip book, I'm always excited to see something move really, really fast. And a
yeah,
lot of times I can, it's already in Sinbad, but I'm hoping one of these days I find it and be like, it's not notified. Good, we found something neat. But yeah, it just
neat.
seems like
Yeah,
not much that much luck, but we'll find it hopefully one of these days.
yeah.
I'm I'm putting all the positive will into the universe to show up. Come on, stop being flaky, Planet Nine.
Go Planet Nine. Go Planet Nine. But we also get psyched, as John pointed out, anything that goes super fast, we get thrilled about because the bread and butter of this project has been these objects called brown dwarfs.
Mhm.
So, anybody want to say what a brown dwarf is?
It's smaller than the sun, but it's still, I mean, it's pretty cold.
Okay,
My
so
memory failing me, even though
Narrowed it
I've
down.
got it.
Um, so a
Aaron,
brown
what?
dwarf is a ball of gas, right? It's a ball of gas.
Oh,
And it's not a big enough ball of gas. I mean, so is the sun, right? A brown dwarf is not a big enough ball of gas to sustain hydrogen fusion like the sun has. That lights it up. Um, that's almost it. Uh, so you could think of
oh,
it as like an almost star, or um, it's also really similar to a planet. So often people will find these objects that they think are exoplanets, and then they discover, ooh, this object is actually too massive to be a planet. It's a brown dwarf. They're super. They overlap with planets. You find a really low mass brown dwarf. It has the same. It's essentially an ejected planet, like a planet that has no star.
wait, the brown. Say that sentence one more time. I'm sorry.
Like a
The
planet that has no star. It's like a Jupiter that has no star.
the brown dwarf is itself.
Yeah.
So it like kind of takes the like responsibility of both things. Like it doesn't fit into either category as a failure to become a star, but not. I don't know. Like, but
It's not failed to be anything. Come on, let's be friend. Let's
yeah, we got some haters out here with
yeah, yeah.
Schwab and
It
us.
sorry, Ashwan. I have to take issue with that because I think it has succeeded as a brown dwarf.
It's very wise.
I mean, I guess if you really like stars, then you might be disappointed that you didn't turn into a star, but
That's pretty funny. I wonder then if or I know one of our guests on a previous SciStarter Live, whose name is failing to come to me, but I've met her on several occasions. She was also at our uh, event for cool. What's it mean to be cool? Oh gosh, what's her name? But she does cool neighbors, and I think she found one of the brown dwarfs. She was one of the finders. She's one of the volunteers. Oh, I forgot her name. I'm so sorry if you're watching this later or watching this on Facebook. I am evil. But she's a lovely human. It's not loose. Something. Oh, whatever. I'll find out later. It'll come back to me later. But she was really excited about it because it was like the opportunity to find something like that was uh she plays this all the time or does this because it means a lot to her and she finds it to be super fascinating. So it was really great to learn from her what it means. So she believes the brown dwarf star or brown dwarf is in its own right to be a brown dwarf. It has succeeded. I think she
brown
would agree.
dwarfs are neighbors. So there's a brown dwarf. There's one brown dwarf for every 6 stars.
Oh, that's cool.
Yeah, yeah. So they fill up the solar neighborhood. So Proxima Centauri is still the closest star, but we're not. It seems likely that there could be a brown dwarf between us and Proxima Cent. Um, it's not ruled out. I mean, wouldn't that be an amazing discovery too? So the third and fourth closest objects, by the way, are not stars. They're brown dwarfs. So there's the Alpha Centauri system, and
Hmm.
then numbers 3 and 4 on the list are brown dwarfs.
Mhm.
By the way,
Hmm.
you mentioned that some of our volunteers have discovered new brown dwarfs in this process. I'll give you a number on that. 97
Whoa,
of
97 have been discovered
our
from
of
our
our
volunteers.
volunteers have discovered new brown dwarfs.
Wow.
And um, 40 of our volunteers have become co-authors on papers. So they're now published in the scientific literature as authors on papers about these objects.
And they're not all coming from science backgrounds. They're just enthusiasts for brown dwarfs and citizen science and universe and whatnot,
They're
right?
just my favorite people in the world, is what they are.
That too. That too. Shoot, I gotta get on finding a brown dwarf now.
Yes.
Eric just asked if there's any binary brown dwarfs. I'm actually not sure what binary means in this case. So,
Yes. So there are binary brown dwarfs, and there are also brown dwarfs that orbit stars. That's more common, as you'll see a brown dwarf that's orbiting a star.
mhm.
And in fact, we've been cleaning up. You, sorry, we've been really owning that field of binary brown dwarfs because that's something that the human eye has been really good at that AI and other tools have bombed. It gets confused when there's another object nearby, but
And remind me what binary
our
means.
crew picks them up. So it's orbiting. So like the Earth orbits the sun, right?
Yeah.
A pair of stars that are similar in mass, they will orbit a common center of mass, kind of like this.
Oh,
Yeah.
very cool. That is very cool. Sweet. And we're cleaning up in that field, it appears.
Yeah. Yeah. We have some new papers coming out.
Um,
Um,
should
you know how
I
many
tr
papers we published, by the way?
how many?
More than 50 papers have come from this project.
That is pretty impressive. That usually
Well, we've had some time. We've been at it since 2017.
that doesn't feel like that long ago. I know what I mean, we're just getting old, but the like but it doesn't feel like it was that long ago. And what like aside from like the number of brown dwarfs that have been found, like what are the types of discoveries that are being written about? Like the like attributes about the brown dwarfs, or what have we been finding out that goes into these papers?
So we found 4,167 brown dwarfs.
Mhm.
Um, and that's about 12% of all of the known stellar and substellar objects out to 60 parsecs. That's um, about 200 light years.
Sure, no big deal. No.
Um, we discovered um, the first extreme T subdwarf, so it's a new kind of brown dwarf. We discovered um, several of the objects that holding the record for the coolest brown dwarfs. So when a brown dwarf is really cool, it resembles a planet. So
Mhm.
everybody in the brown dwarf field is chasing after those, so you can compare them to planets. And we found 15 of these ultra cool brown dwarfs. We found or an aurora, a brown dwarf that has an aurora on it.
What? Is it close to our sun, or is that completely
All of
crazy?
these objects are sort of close, especially compared to the previous talk, right? Um, which was just these very distant galaxies. All these objects are within our own galaxy, and they're all. I wouldn't say you could visit them casually, but you could imagine one day sending an interstellar probe there if you could wait many years. Um,
Very cool. And I'll say it out loud just in case anyone was curious. But the results page of the Planet Nine project does have a bunch of the papers, but it's possibly not super updated. So if there were more, then they'll certainly be added in some at some time. But if you wanted to know more about each individual, so like, oh, extreme T type subdwarfs, that's on there.
yep, we
Uh,
discovered it.
yeah, that is pretty exciting. Was it a citizen scientist who found that?
Yep, yes, indeed.
Oh,
Took
good.
us quite some time to figure out what the heck they were. Uh,
Funny. Do they look different? Like, how do they?
extreme T subdwarfs are objects that are um, very old. We know that they're like brown dwarfs, but old brown dwarfs. And we know they're old because they have um, they are lacking in iron and other metals and other elements, which which take time to form in the galaxy. So
Okay.
um, more recent, newer objects are rich in iron and other elements that are formed in evolved stars and supernovae and stuff like that. So if you see an object that's missing those, you think, oh, that must have must be kind of ancient because they didn't have that back then, you know?
How do we know that they have levels of certain levels of iron and other things? Like, what is the process for that? I mean, that might be getting too far into the weeds of things that maybe are difficult.
Oh no, sure. You've got to take a spectrum. So you've got to follow up these observations with another telescope. We have a very big follow-up program. Speaking of which, our follow-up program includes James Webb Telescope time.
Hey, nice.
And four of our volunteers have become co-Is on winning JWST proposals.
Wow. Congratulations. If any of you are online with us, are you on here? That includes you, or maybe not.
I'm not sure we have any of those folks in that particular
I
proposal.
know someone in our
But
chat wants to become a co-author to eventually then.
yes. Okay. What? So let's talk about Biker Rolls Planet Nine. So, should we do go to the classified page?
Oh, yeah, sure. Which actually, to answer your question, Eric, for how can we be co-authors, I think you just got to do these projects hardcore. Start
I'm
working.
gonna, I'm going to tell you something in
Okay.
detail. So this project, um, now this project is a little bit different than the Cool Neighbors project because instead of showing you like a sort of a raw picture of the sky, it's showing you a difference between two pictures, and it's showing a sequence of differences.
Okay.
So, um, taking those differences gets rid of a lot of those artifacts that you saw in Cool Neighbors. So you see that the images you see here, they've got that noise, but they're otherwise sort of uniform.
Mm-hmm.
Um, so what you're looking for now is if there's an object that moves, it'll show up most often as this thing we call a dipole. And I see some dipoles right on that page. Can you zoom in on just zoom in on yeah. See
Wait,
how
I
you know
want
those cookies that they sell in like New York bakeries where it's like one side is black, the other side's got the white frosting,
to.
and it's back and forth?
Sure.
Yeah. Well, the
Oh,
cookies don't flip back and forth, but that flips back and forth, this thing that you're staring at, and that we call a dipole.
okay.
Like
And that
two.
is a celestial object, or what is a, can you define dipole for us a bit?
That is an object that's moving.
Okay.
So it's it it moved, and then after we moved, we subtracted it. So it's like the black comes from a picture of it in one spot, and the white's coming from a picture of it in another spot.
Okay.
I mean, we took like the earlier picture and we subtracted it from the later picture. So we get a negative image and a positive image, and they're right next to each other.
Okay. Gotcha. I think I
It's a way to
understand.
highlight moving objects to make it easier for you to spot them because we have to get through the whole sky. A lot of data. So that's why we have to like we have to use these tricks.
Gotcha.
Um,
Okay.
so yeah, so you're looking at here a moving object. And that one is reasonably bright, would you
Mhm.
guys say? So that's probably a known object.
Okay.
If I saw something like this, uh, I might want to um, look it up in a catalog of stars and see whether it's there before I got too excited about
Yeah. I found a new thing. Give me credit.
it.
Should I mark it right now? And then,
Sure, go ahead and mark it right now.
okay,
Um,
so it's one of several things on here, but
yeah, we'll just focus on that one for now. And then take a look at along the bottom edge and along the left edge, you'll see these numbers.
mhm.
See those coordinates?
Oh, that's not what I meant to do. Sorry. Yes, I do. So,
So those coordinates will allow you to look it up in another catalog.
oh, okay. So currently there's no way to click a button that says, here are numbers, give me the catalog. Like I would have to go
Wait,
and search.
there is.
Oh,
So if you go to the um
collect?
guys,
Recent?
is this better to do this on the talk page or is it better to do this on this classified page? You have to go to the click on the eye.
Oh,
Actually, let's go to this object's talk page. Let's click done and talk.
okay.
Okay. Now, if you click on the eye to see the metadata,
Ooh, okay.
so this takes you to a bunch of different catalogs where you can look up the object. So
So,
let's go to the Simbad catalog. So click that blue link.
Mhm.
And this is going to give you a list of all of the known star, well, not all, but many of the known stars that are on that page that we looked at. And it'll show you the coordinates for those stars.
Gotcha. And this is just an aggregate of all
So
those over each other?
yeah, so here's some known objects on that page. There is
Mhm.
a IRAS one that's an infrared object. The next one is a Tycho catalog. There's a Gaia catalog object. So these are all known objects. So do you remember happen to remember the coordinates? Let's flip back to the other page and remember the coordinates for that object. And then we'll go back to the Sinbad section. So it's
40,
at 50,
oh, 5845-ish.
yeah, 5845 and
42.
minus 4284. Anybody want to write that down?
I'm gonna write that down, yeah. 45, and then the other one was 4284, but negative.
Yep.
Okay. So then
Okay.
we'll
Got that, Emma. All
Mhm.
right. So do you see an object at those coordinates?
um
Sinbad.
42. So mm for where the coordinates are we looking at this section, I
Yes,
assume?
exactly.
We'll start with
So it was
bubble solid
50.
58. Oh, but it's so the starting with 3, are we just looking at this stuff over here?
So the first coordinate that you wrote down, which is
Uh,
called Great Ascension, is the one that's in the IRCS J2000 RA column. That
okay.
was the coordinate that's at the bottom of the screen.
Okay, so 5845. And this one doesn't go up to 5845. Or am I looking at the wrong spot? I could change it on here. This is just like too low or just not the right number? 58 is the number.
I see, I see.
Yeah.
Um,
Sorry, I'll zoom in more. It's probably really hard to see from you. Eh, Zoom shared screen is never optimal. Like, could I change?
I see. This is in um hours instead of in degrees.
Oh, do you want me to use a different reference point so we can go to a different instead of Sinbad? Will that make it better?
Sure. Oh, well, okay, let's look it up in Vizier.
Okay.
Let's see
And
how
I see Ashwan said we can also use IRSA Finder chart to precisely
hard to
find.
get the coordinates. Oh, that's a good idea. Okay, yeah. So yeah, let's follow Ashwan's suggestion
Okay.
and use Ursa Finder chart.
Oh, is that down here? Yeah.
Yep,
Finder.
there we go.
Yeah, I always cheat. I go into the backyard worlds viewer that you guys created, and then I click and zoom into it and change it into the decimal, and that way it's easier to put it into some different toolboxes or visors.
Oh yeah. That's a good idea too. We
Okay.
have at this point we've developed a whole bunch of different tools to help with this stuff.
Okay. So direct me on how I should be looking it up here though, because I'm not sure.
Okay.
I'll zoom
So
in. I have 58.45 and then negative 28.84. I classify these frames.
so now we've got to find that same dot,
Mm-hmm.
which I think it's the one. You see that yellow circle? I think it's the one immediately to the right of it. Sorry, I'm pointing at my screen.
Oh, 1, 2, or 3.
Um, those are all the same. That's all the same patch of sky at different bands. Yeah, I think it's that. Doesn't that
Okay.
look familiar?
I suppose, but I don't have practiced eyes in this. So, oh, if I hover over it, does it give me
Does it give you coordinates?
42? It gives me the 42, I guess.
Mhm.
But I don't know if that's what we're. So these, like, they're not equivalent in my brain at this point. Should this 50, where that's like right now it's hovering over 56.93. Should that be a 58 or is that not what those are times. How do I find or where am I looking at for these coordinates? Because I have what's written up here, but that's not what I expect to see, I guess,
Right.
as a person who has never done this before.
The thing that's up there is the coordinate of the center in the frame of the frame. And we need to get to the object that you spotted.
Yeah, it might be easier, Mark, for her to go
Is it
back to
easier to
the.
do this in Wise View, John? Do you think?
I go have her do the wise view, and
Okay.
Okay.
it's going to put you in the same coordinate spot, and she should see that. And what I would do is leave that alone in the top left. I go
Hmm.
over and I physically once it renders, you'll see that big dot up there that's moving. Just go over and click on it. It'll give you the new coordinates in the left, and then you can paste it to wherever you want.
Yeah.
Yeah, that's you go when you guys wrote that. That makes it for
Oh,
newbies pretty easy. And then you can take that and you can put on some different things. And then I actually
Yeah.
take that
Yeah.
and put it in the Astral Toolbox and see if the different catalogs. Because Visor is kind of it really is intimidating for me at first, but
Yeah.
I
Yeah.
actually understand how to read it now. So that's how I use it. But everybody's a little different.
I didn't realize just how many tools and catalogs there were.
Sorry, the project has really kind of exploded. This
There.
is this tool that we're looking at is written by Dan Castleton. He is one of the citizen scientists on the project.
Oh, amazing. Very well done. So did I get it
So at
to
this point, the thing that
this?
you clicked on is now it's now telling you the coordinates in that box where it says right ascension and declination. That's now the coordinates for it.
Okay. So I'm gonna copy that.
You
Where do
you
I?
were pretty darn close.
Oh, like with guessing what the coordinates should be?
Yeah, yeah,
I'm good at
right.
guessing. Estimation is my strong suit. Absolutely. Yeah, it looks right
Yeah.
to me. That
So,
information, I would be able to see where would it tell me if it has a name already. Would that be in here?
so copy those coordinates and let's go to Simbad.
Okay.
Um, and then let's do a new query. That box? Do a query for those exact coordinates. So just get rid of what's in that box and do a query for paste what you had in there.
I think I did. Let's
Yeah.
see if it, oh, did
Yeah,
I?
just go up and hit go back onto your Simbad screen
Mhm.
and go scroll up, hit coordinate search. That'll wipe that out for you. And then you can go down, you can paste your coordinates right there.
Well, it's a
Okay.
good thing you're here, John. I wouldn't have been able to explain this very well. Ooh, there's no astronomical object found within two
I
arc minutes.
discovered a star.
You may have discovered a star, in fact.
Well, what I've learned from you guys, Mark, is sometimes it'll actually be in Visor,
Yeah,
but for some reason it didn't make it into Sinbad.
yeah. So, if you got that far to find an object that's not in Simbad, then it's
Hmm.
already time to report it to indicate, leave a note. You say not in Simbad. In fact, we have a hashtag not in Simbad. Leave the coordinates for it too.
Is it one? Is it going to show up?
Yeah,
Uh,
that's good.
let's see if I can.
Yeah, and there's no wrong way of doing it. This is how I do it. I always put in
Yeah,
RA space, the right ascension and space, declination space, and the
awesome.
coordinates, and then I put not in Sinbad, and then if
Hmm.
it's in Visor, and then I go in and dive into the Visor catalog, and I normally look for Catwise and Allwise and see what I've got for W1, W2, and then I go look and see what I got for actual proper motion on the right ascension and declination.
Okay. Again, I'm
So
shocked.
yeah, so if you make it this if you found something interesting like this,
Uh-huh.
then we have all these tools and they're all described in the FAQ. So why don't you leave this comment? So go ahead, click on add your comment and
Else
make
I
sure
need
it's accepted.
to add? It seemed like there might be something else I need to add, but did I mishear? Is this
You're good.
enough to?
That's already pretty useful.
Okay. Add my comment.
Useful comment. And then
It will be named after me. I expect it.
of course. So, let me show you if you have something interesting. We have can you go to the FAQ page that describes all these different tools and things?
Oh,
FAQ page, this has got everything.
sweet. Okay.
Um, I think we're one of the first universe projects to have an FAQ page. Proud of that.
Well, they definitely are very useful, so I'm glad they exist for all
Um,
projects. Oh, good. It was the right one. That's
so we have, if you search around this page, you will find something called the Think You've Got One form. There it is. What do I do if I think I discovered something?
good. Oh, okay. Please fill out this form.
Please fill out this form.
Login. Subject number. Uh-oh. I did not have it open. Hold on. Recent.
You get used to it.
Uh-oh.
Once you
Ah,
start discovering stuff.
you just start remembering everything. Yeah. Okay, hold on. Which one was this? This was Planet Nine. Okay. Recents. There we go. Okay, so this is the URL. Subject number, it's at the end of the URL.
There you go.
Oh, subject's ID number. Oops. Sorry, those are just gonna add more ID number. It's at um or wait, what
Click
was
on
that?
your eye again.
Click on the which one? The I?
Yeah, click on the eye. It'll be on the very top where it says ID right there for you.
So Eric asked a question in the chat, how do you become a co-author on paper?
Yeah.
And the answer is that every couple months we go in and we harvest what people have submitted on these forms. And so far, all of the co-authors of papers have gotten involved in this way. People have sent in so many interesting objects using this Think You've Got One form. That's how we've met. Uh, that's how we met John. That's how we met Lisa. That's how we met Sovan. Um, and that's how all these more than 4,000 brown doors were discovered. Submitted
Well,
on.
what made the paper that we just had done work was what's kind of nice with that one is that one actually Dr. Kirkpatrick actually gave us each 10 stars at a time, and that was really fun because the I'm actually the ambassador to Altar is what he gave me, and it seemed like the first few stars he gives you had a lot of data you could find it, and there was a lot of stars that was really interesting for being 20 parsecs away from the sun. I couldn't find anything, but I started looking at different observatories like in Germany, all over the world, and was able to get different things. So it was like about a 3 month project for me to do 60 stars for that paper. But I will tell you one thing, I learned a lot, and it actually made it better for me to be a better observer and look out in this program. So yeah, I keep telling Davey I'm ready for another paper.
That's fantastic.
Nice.
Yeah, so and sometimes people will submit something. Like I think this happened in John's case. He submitted some objects and they turned out not to be scientifically interesting, but
Oh.
we're very interested in John. So John started attending um, our science team meetings and got involved in a side project, and that bore fruit.
This is
But
I'm
now,
actually
but now, Mark, I'm actually on your list now for hopefully some kind of a new object. So at least I'm happy I finally made the cut.
Finally, yes, finally struck gold. It's it's a lot of luck involved, right? A lot of luck.
oh my gosh. If it was me, I would just give my coordinates and the details of the object to my moderator so that it would be eligible for think you got one for him. Yes, can just give any coordinates. What about your own the human coordinates on Earth? Has anyone ever tried to punk y'all and put coordinates on Earth? I hope not. That would be confusing. But
Yeah, the
we're
sky coordinate system and the Earth coordinate system are pretty darn similar.
yeah.
That would be confusing.
I mean, looking at the coordinates here, I was not sure exactly how to or yeah, they look very similar. You're right.
Yeah, yeah, I
Nice
agree.
system to be able to have a very similar.
Well, the
um,
one nice thing about Mark's team is he's got a great set of core moderators. They all help each other out. If we, especially when I was new, didn't really know what I was looking for. They gave me ideas and tips and stuff, and then bounce ideas off them. So it's nice that you can work with PhDs with someone like me that doesn't have a PhD and a little bit different background, and be able to put it all together as one piece and make a bigger puzzle.
yeah, that is a very beautiful sentiment to be like you're just a part of something way bigger and really, really important. So I appreciate that. And I apologize, we're about 2 minutes out from the top of the hour, so I just want to ask for everyone here for this project and just as a learner or as an expert here, I want to know what the words of wisdom are. If Mark, if you have words of wisdom, or if any of your team members have particularly good thoughts about how to move forward on this project and what your favorite things are, whatever you'd like to share. This is the
Oh,
moment.
Nana asked in the chat, is it necessary to be physically present to be a co-author? No. Um, just need to either luck out and discover something,
Mhm.
or hang out with us on the science team Zoom calls.
When are those?
Those are multiple times per week, and if you submit objects on the Think You've Got One form, then you get an invite.
Ooh, I'm gonna get an invite now?
Yes, it might take a while.
That's okay. That'll be fun. Oh, and Eric says do not stare at the frames for too long. Okay, it's good to know too. Then you'll feel like your eyes are turning into the noise that it's
Yeah,
creating. You'll only see it forever.
the Think You've Got One
No, he's
form is,
correct, because if you stare at the screen, your actual eyes will start making objects move.
Oh, it's like you're just hallucinating at that point, just too much going on. Too much you've looked at. Perfect. Well, oh, a good way to find a mover is if it is dancing differently from the other objects. Hint from Mark, too. Some good advice. Dancing differently. It also is just very nice advice. I like dancing differently. Oh, and there's 7 of us online right
in
now.
the chat, by the way.
Well done. If you really want to look out
Just so
the,
you know,
what was that? Oh, awesome. Yeah.
put me in the chat in case.
That goes to or actually, hold on. I'm going to resend that to everyone because I think it only went to the hosts and panelists. There you go for
Okay.
everyone. Um, if you really want to look out the object like a real scientist, I would recommend just open up Legacy Survey. Legacy Survey. Is that the one that, do you mean like it'll be easier to find out what it is? That was from Ashwan. Dipoles with diffraction spikes are possible stars most likely discovered already. Well, whatever I found is definitely a new thing, and it's probably your 9th planet. No, I don't. I found it. It gives you a digital survey of the images. Oh, okay.
Yeah,
Um,
that's a really good tool. Um, but it doesn't highlight moving objects in the same way that ours does. So it's probably not as sensitive to really faint things. The objects that we looked at, they've been pretty bright. Um, but there are some movers in there, some dipoles in there that are just, you really gotta be magical in order to spot them. But there've been some real discoveries in there.
yeah.
Well, I think the couple I found, Mark, I think they were so dim, and they almost had the fall off the on the scale of the W1 or 2, mainly the 2 drop off. And so you really had to zoom in and look at them, and look at them a bunch of other tools to even see if they were really moving. And then normally the visor would show you that there was some proper motion in it.
Yeah.
I am very excited for the potential of my discovery to make it into a publication. I will not hold all my hopes on that, but I am very excited that the first thing I looked at was something interesting enough to put in there. So very nice. And since there were so many of us here, I think we had 16 of us at the max. Yeah, 16 at our max amount of people. So that'll be 16 acts plus my one, which will be counted because I was an affiliate project. But let me go ahead and write out a couple of our names. So John, Mark, Eric, I think. Yeah, Eric, Ashwan, Nana, thank you. So all of you who are awesome, where to access the meets? Oh, yeah, answer. Gotcha.
Yeah, send me an email.
Perfect. Nancy, you're here. Thanks for sticking around almost all day, Nancy, by the way. Oh, I just typed the wrong one. Nancy. And this is officially the last moment of the 12-hour 12-hour.
Must be exhausted, Emma.
I was around for more than I thought I would be today, so a little bit, but that's okay. It's all fun stuff. I've never done more citizen science in like a day before, so this is pretty exciting just to see like how well I did all day. But it'll be interesting to try this again because I think this was very well received. So I'm excited to see we might be able to do this again in the future in a different way. So if we can keep our eyes open for more events that could go this way, I'd be pretty excited. And then I think, did I miss any names? My own. I think we might be okay. Oh, Darlene, I see you. Oops. Oh, Michael, thank you. Sorry. Can't believe I forgot. Or I can't believe I didn't see your name on there. Awesome. I think that was okay, cool. Oh, it's because you're a panelist, Michael. I'm sorry. I didn't realize you were still on the panelist list. All right, just double checking the thank you. Yeah, absolutely. Thank you so much, Nancy, for joining us. And thank you all of you who are in Planet Nine and for Cool Neighbors in general. I am so glad that all of you could join for this. That was so many of you, which is pretty exciting that you guys are still super into it after as many years as it's been a thing. So be excited. I'm excited. I'm definitely gonna do more of that now that I've discovered one thing.
Yeah,
But
it's addictive.
it's addictive, yeah. Oh, all of these projects. Every time I've done a project today, I'm just like, so I'm gonna keep doing this, but I have to switch right now. So thank you for showing me how to do this, and then we'll continue it another day. Awesome. Yeah, thank you everyone. Oh, no worries at all. Yeah, no worries at all, everyone, for any information you want to share. We'll definitely do this again, so stay tuned for the next time we do something just like this. Maybe another NASA Power Hour marathon, right? Do another one. Should be fun. Awesome. Thanks so much, Mark. I hope you have a lovely rest of your evening for those of us who are in bedtime mode as opposed to morning for some of you, it sounds like. Awesome.
Thanks for having us, Emma.
Yeah, thank you. Yeah, I'm serious. We should definitely do this type of event again. It sounds like it was pretty exciting or pretty well loved by those who were here with us to get real experience doing the projects too. So
Yeah.
cool. Okay, everyone, I'm going to go ahead and end also from Facebook. So bye, Facebook. See you later. So that we can all